Hello. Yes, ma'am. Yes, ma'am. Am I audible, ma'am? Yes, ma'am. Yes, ma'am. Yes, ma'am. Good afternoon, ma'am. Okay, ma'am. Okay, ma'am. Okay, ma'am. Okay, okay, ma'am. Good afternoon, ma'am. My name is Lagan Saifi. I am from Madhubani, Bihar. Currently, ma'am, I am pursuing Master of Technology in Microelectronics and VLSI Design from NIT Silchar. I have completed my BTech in 2022 in Electronics and Communication Engineering from University of Allahabad, Prayagraj, Uttar Pradesh. After completed my BTech, I have joined the Government Polytechnic College, Samastipur. In that college, I have done 1 year apprenticeship training. At the time of training, I have taken the classes, management, so many things. Any particular, uh, any particular like technical in every curriculum I have participated, and yes, I have learned so many things. After completed my training, I have joined the government the Lakshya Polytechnic Institute as a lecturer, and I have teaches at there 6 months. After that, I have come to here for MTech. So this is my educational background, and in here in NIT Silchar, I have done project in this time. I'm modified low power up down clipping counter for in memory computing system. This is my project, and I have written this paper also, and for the last date of the 15 in VIT below, I will go to submit my papers also. I have completed my paper, and I will write the thesis on this paper, ma'am. Yeah, thank you, ma'am. Ma'am, this is my third sem project, but I want to submit in this time, and I want to extend my work also in along with this project. So still I have done this
इसमें क्या
project,
है
ma'am.
भाई?
In 2026, ma'am. May in last May my coursework has been completed. Yes, ma'am. Yes, ma'am. Last in May. Yeah. In this time, I have a PPT also, and I want to choose. Actually, ma'am, I have already teaches and my YouTube channel also. And there I have teaches my one YouTube channel, Get a Sphere. So I have chooses the basic fundamental in a network circuit topic is KVL KCL, and I have a, PPT also. So uh, if you tell me, ma'am, then I will. Yeah. Okay, ma'am. Okay, ma'am. So I will, ma'am. Can I share my screen, ma'am? Okay, ma'am. Ma'am, it's visible, ma'am. Yeah. So, ma'am, I want to explain the Kirchhoff's law. Basically, why I have to choose this topic, because if a student is coming from EC background or electrical background or electronics and instrumentation
नहीं
background,
करने का ऑप्शन दे रहा है ना,
basically
अप्लाई करने
this topic is very important for the fresher, for the initial student, because if the student know the KVL KCL, in very good way, very good manner, then most of the topic, most of the subject, I think he has been understood very good way, like analog electronics, like control system also, and obviously network circuit is very good. So these two topic, KCL and KVL, is very essential for the student, ma'am. So I want to explain what is the KCL and what is the KVL. So firstly, KCL is based on the law of conservation of charge, which requires the algebraic sum of charges within a system cannot change. Okay, so basically KCL is based on the law of conservation of charges, ma'am. So what the KCL said? KCL is, it states that the algebraic sum of currents entering a node or a closed boundary is zero. That means if I have a particular node, so at this particular node, the algebraic sum of the currents, that means if suppose current is I1, if this branch current is I2, current is I3, and current is I4. So at a particular node, the algebraic sum means I1 plus I2 plus I3 plus I4 is equal to 0. So this first statement is saying this thing, and the second definition is the sum of the currents entering a node is equal to the sum of current leaving the node. That means at a particular node, if current is suppose this is I1, this is I2, and this current is I3, and this is I4. So what this statement tells, if a particular node, the total current, incoming current is equal to total outgoing current or total leaving current, that means I1 plus I2 is equal to I3 plus I4. So basically these are the two definitions of the KCL. Okay, so this is KVL. Second law is the KVL, Kirchhoff's voltage law. So according to this law, actually this law is basically based on the principle of conservation of energy. So what this tells, this KVL tells, so it states that the algebraic sum of all the voltages around the closed path or loop is 0. That means suppose this is the batteries V1 and V2, V3, V4. This is the voltage across these resistors, and if we sum the algebraic sum of all the voltages, like minus V1 plus V2 plus V3 plus V4, then it becomes 0 in a closed loop or closed path. So these are the two laws given by the Kirchhoffs. And with this example, I want to explain the voltage KVL. So I have taken this example. Yeah. Yes, ma'am. Yes, ma'am. Firstly, ma'am, KCL. Yes, ma'am. KCL and KVL. I have two examples. I am taking two examples. So this is basically dependent source along with independent source. And in this example, I want to explain the KCL. And in this example, I want to explain the KVL. Okay. Okay. So in a particular example, I will tell, ma'am. Means firstly along with KCL, then KVL. Suppose I want to, yes, ma'am. Yeah. Means in this example, firstly I want to explain the KCL and then KVL. So in any circuit, if we have to solve how in any circuit how to find the current and voltage. So firstly firstly the Ohm's law I want to explain, and after that KCL and KVL for the solving any circuit, ma'am. Because some basic parts is also already done in the 12th standard. After that, when the student is coming in the BTech, then I want to start from this topic. Yeah, ma'am. So in in digital electronics, ma'am, and control system also, digital electronics, signal system, and in the MTech point of view, ma'am, digital VLSI design is my best topic, and I have the best subject, and I have done my project on this subject, ma'am. Okay, ma'am.
Yeah.
Okay. So, ma'am, in a pole, yeah, yes, yes, ma'am. Okay. So, ma'am, in any given pole, firstly, is the raw service. Yes, ma'am. Okay, ma'am. Okay, okay, ma'am. So, suppose, ma'am, I have taken. Yeah. Yes, ma'am. S plus 0.5, ma'am. You have taken. Okay, ma'am. And S plus 1.2. Okay. Okay, ma'am. So basically, zero. Firstly, in the numerator, zero is the one, and zero is minus one, and this is poles is, that is zero, and poles is 2, and minus 0.5 minus 1.5. Okay, so I want to represent, this is minus 1, let's suppose, and firstly 2. Okay, okay, so suppose 1 2, suppose 0.5, like minus 1 and minus 1.5, minus 2, and minus 2.5. Okay, so minus 1 is pole, and 0 is, this is equals to 0, and second minus 1.2. Okay, so here is of poles. I will represent. Oh, no, no, oh, no, ma'am, I have not redraw. Actually, yeah. So 0 is minus 1 is the 0, and minus 1.5, this is poles, and minus 1.2. So like here, one pole is minus 1.2, this is minus 1.2, and this is our 0. Okay. So, ma'am, in this system, these two are the one is yeah, 2 also, ma'am. Yes, 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 ma'am. Here 2 also. Yes, ma'am. Yeah, ma'am. This system is unstable, ma'am. Yeah, because, ma'am, if we think about these two poles, so these poles is a start and going to 0 here. So suppose if we think about this pole, so for this pole, if start from the pole and ending with the 0, for this pole direction is like this, is going for infinity, minus infinity. But one pole is in the right half plane, so because of this pole, the system is unstable, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. Because, ma'am, if we think about the stability, then raw service criteria is not fulfilled because of this right hand pole. That's why, ma'am, if we are thinking, So according to the Roth ellipse criteria, all the poles and zeros are in the left hand side. Then the conditions all feel fulfilled. Then we can say it is a stable or unstable system. Yeah. My career plans, and actually I have teachers from BTech second year as a home tuition. So 4 and 5, 6 I have studied teaching, ma'am. So I want really interested in teaching, ma'am. And my future is goal is obviously done PhD, and in this time I want to do job, ma'am, as a in teaching field only. And after that, along with my teaching, if possible, then I will join PhD also, and I want to do in